Hi, this is Miss Litton, and this is a teeny tiny little review. Say hi. Hi. These are most responsible students reviewing chapter 27. The quiz is not tomorrow, but they saw the review for chapter 27 was for today, so they showed up, and I am so proud of them. Okay, so the first thing we need to do is talk about how old the universe is. How old is the universe?
14 billion.
14 billion. So if we were going to make a list, right, we would start with universe. And we would say it was how old? 14 billion years old, right? What comes next? The Earth. How old is the Earth? 4.6 billion years old. Good. Okay, make sure if you're not in here for this review, you're not talking too loud so I can record this. Now, let's talk about that early Earth and the conditions of that early Earth. It had a rocky, what? Globe. Okay, rocky globe. And what are the edges of that globe consisting of? What moves around on top? Tectonic plates. And do you remember the three different interactions we said for plates? What were the three interactions? Divergent. Okay, so divergent is they're going two different ways. Two me another one. Convergent, so they're going towards each other. Now let's talk about those convergent plates. What were the two, there's two plates coming at each other. What if it is a continent plus a continental plate? What will we get? Mountains. Perfect. All right, what if it's a continent and an oceanic plate? What will we get? Subduction zone. Good. And what can happen with that subduction zone? What could you get? Not seafood. That would be here. Yeah. What is it? What? Subduction zone with a volcano. Yeah. Plus a volcano. Good. All right. Then what was the other one? Ocean and ocean. What could happen there? Still islands. Yes, I was making islands in the middle of the water with, okay, islands. Good. Now, I did hear one here I really wanted to do. If it was ocean diverging from ocean, what do we call that? That's what you just said. Seafloor spreading. This is such a messy board. Floor spreading. Did we see continent going away from continent? Where did we see that? Oops. Continent. Where did we see that? Remember in Iceland when it showed the continent going away from each other? Okay, cool. Okay. So we have two of our three. What's the third one? Transform. Right? And that's when they are going past each other, right? Do we see that here? Yes. With the Pacific plate and the North American plate. And what does that cause for us? Earthquakes. Okay? Now, the next thing we want to talk about is what is causing all of that movement? What's causing these plates to move around? Convection currents. Okay, good. Perfect. So that was caused by convection currents. Now, convection currents moving around. That's a terrible arrow. Okay, so we have these convection currents going. What's generating these convection currents? It is magma moving. The core. Yeah. Why is the core so hot? Radioactive decay. Good. What else? Pressure. And what else? The watch. What am I telling? Time of formation. Yeah, that too. Okay. So at the time of formation, there was a lot of heat, right? Then continual pressure because it's that solid core, and then you've got isotopes breaking down that are moving it around. All right? And remember, we already know that the Earth is not flat. We have some evidence for that. Okay. So that's what makes these convection currents move, and that's what makes the plates move that are sitting on top of them, right? You good with that part? Okay, we did that, we did that, we did that. We did all of that. Okay, these are those. We remembered that. We did that. We don't even need to look at that. Next, evidence for plate tectonics. You know, and we were trying to look at some different pieces of evidence. And one would be all of these what? Volcanoes and earthquakes are evidence. Yeah, so volcanoes and earthquakes. And then do you remember some other pieces of evidence we looked at? Fossils. Okay, so that was saying when the plates were together, the continental plates came together, what was that supercontinent called? Pangea. And when you had Pangea, I'll jump ahead, I need to go back to that. When we looked at Pangea, we said, okay, if the continents were all together, it makes sense that you have this continuity in fossils if the continents were together. And then we looked at some kind, I added on there that Antarctica has fossils of like reptiles and lizards. And we know Antarctica, it's too darn cold there now. So Antarctica as a continent must have been located before a place where it was what? Warmer. Mm-hmm. And then all the continents were apart from each other by 65 million years ago, and that's about the time what was evolving? Not humans, mammals. They have hair and breastises, okay? That's what mammals have. So about the time mammals were evolving, the continents were apart, and that's why you get such unique mammals on these different continents, because when they were evolving, they were separated, and those mammals couldn't go across all that amount of water. Okay, so that's evidence for Pangea. We also looked at other evidence. When we talked about seafloor spreading from oceanic plates separating from each other, that's going to be filled in, and what is that going to be filled in with? He's right there, right here. It's going to be filled in with magma. And when that magma hardens, it will harden based on where the magnetic North Pole is, the direction it hardens. And we can see when we look at that hardening and that it has switched back and forth, north-south, north-south. Okay, that tells us a couple things. That tells us that the poles used to be reversed. It also, we can see the patterns make sense with the lava coming out and hardening, hardening. And so you can tell, especially if you look at this picture, magic pen. Am I recording? Yeah, I am. Okay, good. Okay, when we look at this picture, this dark line right in the middle, okay, that's where you have delineation on either side. These are 20 million years old, but these are what? 120 to 63 million years old. So they're older, and then it would be older. The newest one would be coming right out of here, right? Does that make sense? Okay, perfecto. And then the last piece of evidence we talked about is looking at the depression that are caused by large bodies of water or ice sheets on continents are causing depressions in the land below it. That can only happen if you're what? Floating, right? Not floating. All right. So now, we talked about at the very end is how geological features can affect living things and how living things can affect geological features, right? So if there is no oxygen on land, early Earth, right? Because the oxygen revolution was about 2.3 billion years ago. If there's no oxygen, you can't do efficient cellular respiration. So all the organisms were just how many cells? One cell. But once there was a mutation by life to generate oxygen, now organisms can be more efficient in cellular respiration. Instead of being unicellular, you can be multicellular. And then these living things are creating a what? Ozone layer. The ozone layer is protecting the life below it, so now they can crawl out of the water and they can walk on land. Now they can alter the land just by living there. If you've all been to Yellowstone, right? If you've been to Yellowstone, you might be able to see those, boiling puddles of water where archaea live, and they are creating rock formations by just being there, right? by the reactions they generate. So that can in turn change land. All right, now I want to go back to the very beginning here. Okay, universe 14 billion years old. Earth 4.6 billion years old. Okay, what's our next one that we would say? Nope, something happened before that. Yeah, life. Okay. So let's start our life, because our oldest fossil is 3.6 billion years old, yes? But let's walk through how that would have. Who would have come first? Just the one that generated the membrane, right? That's a protocell. But what did we have to do to get there first? Remember the steps to get to life. Remember that?
Yeah, inorganic to organic.
Yes. So to get to life, we first had inorganic molecules, inorganic, and those probably came out of what? Volcanoes. So here's a volcano erupting with those inorganic molecules. But we also had water coming down, right? So now we have bodies of water, and we have those inorganic molecules are in, oh, hi, Pin. Those inorganic molecules are in the water, yes? Okay, what do we have? What kind of energy forms do we have? We have the sun, right? Shining energy down. What else do we have? We have lightning. Okay, what else do we have? Molten magma, right? Here's some UV radiation. Good. We have molten magma. What else do we have? Oh, yeah, isotopes. So that would be the energy you need to take those inorganic molecules and make them what? Organic. I need just a pen. Okay, let's be calculator. Okay, I'm a pen. So inorganic now to organic. Okay, these organic molecules would be simple, what's called monomers.
Okay.
Remember this? Monomers, like amino acids. What else? Glucose, sugars. Amino acids will build the other ones. Yeah, we're just not to that point yet. Okay, there we go. Now I have more room. All right, so those organic molecules would be things like sugars and amino acids, right? Those are the monomers. But then what needs to happen is those organic monomers need to become what? Polymers. Good. Now, polymers would be when sugars become more complex carbs. Yeah. And amino acids become proteins. Okay? You have all the same energy that you had before. Okay? You have all the same energy as you had before, but also you would have these puddles or pools that water would be evaporating out, and then the surfaces of clay. By the way, look right there. Every 246 day,
135, right?
Every 135 day, you will have tutors that have taken AP biology and been very successful sitting at table 5. Free tutoring. Tutoring costs $20 an hour minimum. If you were getting a teacher to tutor, you'd be $120 an hour. Okay? These guys do it for free on 135 days at Lab Station, Monday through Thursday, right? Or is it Monday through Thursday? Oh, Fridays too. Monday through Friday. Do you hear those out there, students missing this amazing review? Monday through Friday, if it's a 135 day, Lab Station 5, you have free tutoring. Take advantage of it. Okay, these guys are super smart. Okay, they will do a great job. Okay, and you remember all of this, right?
Yeah.
Okay. All right.
Yeah.
Okay, so they're like, of course I'm going to say yes. Okay, so puddles on surfaces of clay, that's how you could have formed those complex polymers. And also we're talking about nucleic acids. And you know nucleic acids are things like DNA, what else? RNA, and ATP. Good. Now, I want to come back here because I forgot to talk about this. This little bit right here, inorganic to the organic, somebody, yes?
Oh, I was just going to ask, how do you get the sugars to the nucleic acids and all that stuff?
Oh, how did you do that? Same energy as before, or the surfaces of clay, also clay, a rock, the clay, can act as a catalyst. They could be concentrated in pools. So the same building that took place here could take place here. And all of this can take place because what kind of environment is it? Yes, a reducing environment. Okay? There was no free oxygen. Okay? That's why it could happen. That's conducive to building. Yes?
There was still some just no free, like carbon dioxide, right?
Oh, there was carbon dioxide. The only thing that you didn't have was O2. You had oxygen in water. You had oxygen in carbon dioxide, carbon monoxide. You had oxygen there. Free oxygen, where it's just O2, is highly reactive. And so it tends to break things down. Because it was a reducing environment, it's more conducive to building. Okay? Yes?
So what is a catalyst?
Catalyst is anything that makes a reaction take place. All right, now, here, this inorganic to organic, somebody did an experiment and tried that, where they had this apparatus and they shifted it around and they had sparks of electricity and they had heat on it. Do you remember the name of that guy who did that experiment? Yes, Miller. In just a little over a week, he was able to take the things he modeled, that early Earth gases, and he circulated them around, and he was able to form those amino acids and those sugars. Okay? All right. So life, now where we left off, if you look at the one before, universe is 14 billion years, Earth is 4.6, and then we have our first fossil at 3.6 billion years, right? All of this had 1 billion years to happen, right? All of this had 1 billion years to happen. So when we, let's see, go smaller still. Whoops, no, here. Okay, so when we say life 3.6 billion years ago, we need to go through the steps where it goes inorganic to organic, monomers to polymers to a protocell. And remember, a protocell just has a cell, what? Membrane. Just has a cell membrane. And then that would go to a true cell that is self-replicating. Okay? That first true cell was probably what type of cell?
Heterotroph.
It was a heterotroph.
This is not for the people who are listening, having to listen to my voice.
Why? I think your voice is beautiful.
Oh, it's really annoying on camera.
No, I'm sure it's fine. What else?
Wait, I have a question. Is it organic polymers or just polymers?
Yeah, it's organic. Once you're organic, you don't go back. Okay.
Not always organic.
Yeah.
Okay.
Okay, wait. So we're going, a true cell is self-replicating. It is a heterotroph. It was probably what else? Tell me. No, it was a heterotroph. No, it was not multicellular. It was unicellular. What else? I'm looking for another word. Prokaryotic. Remember remember? No membrane enclosed cells. Okay? Then after this early cell developed, then you could have an autotroph. And then, good grief. Okay, then you could have an autotroph, and then you could have an autotroph that produced what? Yes. And that was the
Oxygen revolution.
Yes. Okay, so now our 4, oxygen revolution. Oxygen revolution. Sorry, I was looking at my phone. These notes are just fantabulous. Okay, oxygen revolution puts oxygen in the air, which creates a what? Yes, ozone layer. So now organisms, yes, can crawl out onto the land. Go out onto the land, and instead of being unicellular, they could be, yes. Lovely. Yes.
Am I mixing this up with something else, or did oxygen kill a bunch of them?
Yes. Initially with the oxygen revolution, your brain is right on task. When the oxygen revolution first came on, remember it killed almost all the life on the planet because oxygen would be what? Poison. Yeah, poison. Yeah, a poison gas. But those organisms that were able to use that poison and develop cellular respiration using that oxygen, they generated even more ATP and they outcompeted other organisms. And so it was like it was turning into that ice globe for a while. But what re-put the gases back out in the air so it wasn't just oxygen? Volcanoes. Because the plates were still moving, because the convection currents were still convecting, yeah. And so volcanoes were still happening, you still had subduction zones, and so you still had volcanoes happening, and so it then caused the earth to warm back up again. Exactly, perfect. See, such an easy thing. All right, now let's go somewhere and see this. So remember steps of life, okay? No? Okay, so we have inorganic molecules. These are much neater. Inorganic molecules like that what came out of a volcano. Energy, what kind of energy did we have? Yeah, UV radiation. We had lightning. We had magma and radiation that would help us go from inorganic to organic. And who did an experiment to do that? Miller. So now we have these organic sugars, amino acids. So now we got to hook these together to form the polymers. Okay? We still have UV radiation, lightning, magma, radiation. We still have that, and then water could have evaporated out of little pools and concentrated them, or the surfaces of clay, the surfaces of clay. As clay can act as a catalyst to make those reactions go forward. Now we have proteins, carbs, lipids, nucleic acid. Cells. That first cell was a protocell. All it had was a cell membrane. Membranes are made out of 4 things, but 2 things primarily. AP biologists, what are the 2 things, the big things of a cell membrane? Phospholipids and proteins. Good job. And we saw operins, cryosorbate droplets where it's lipids and those proteinoid microspheres. The thing you want to get there is that naturally occurring spheres of proteins and fats happen, and if those combine, that could have been an early membrane. Self-replicating. Who probably came first, RNA or DNA? RNA first, yeah. Because it can act like an enzyme, and you can use it to code for proteins, and then DNA probably evolved as a form of storage. Okay, and that's when you got your cells. Your first cells were prokaryotic, uni or multicellular, unicellular, auto or heterotrophs, and then autotrophs evolved, and then autotrophs that generated
Oxygen.
and then you could have organisms that could be multicellular, and you had a ozone layer so you could crawl out on land and survive. Boom. Okay? Love it. Remember this? Take a picture of it. Take a picture. No, I could hear you whispering. Okay. Yeah, I think that's good. You want to answer some questions?
Can we do quizzes? Like, can you host a quiz?
Yes, I can host a quizzes. I'll post one. I don't know if I have one for this or not, but we'll close down this review. Oh, did you want that back? Are you sure? Okay. Yes.
Okay, difference between polymers and macromolecules. Like I've been
Nothing.
using them because I've been using them.
Yeah, same
like,
thing.
Have I said?
Yeah, nothing. You got it.
Okay.
Okay, walk out that door. Don't turn around now. Don't turn around now.
Literally,
I don't want to see you anymore.
My
You
new
should
is
have
like 4
changed
pages.
that
After
lock.
4 pages, I
You
finally
should have thrown
understand
away
it.
that key.
I feel like that was really nice.
I don't use that L word. She still doesn't know me very well yet.
I know we can talk
She'll get used to it.
try the chapter 27 quizzes or the one you
I heard you say that. I don't have one. I'll go look and see if I have a 27. I have a 1.
I couldn't find the one.
I put it on Google Classroom. The 1, chapter 1, I put on Google Classroom. Okay, let's go in as your favorite food. Sure, top ramen with egg.
I just wanted to ask my soup.
Hold on.
Oh yeah, you're probably still your soup. It's fine. That's right. We were soup.
Oh, your favorite food?
In and out. Yummy food. I don't know. Okay, I'm going to start.
Wait, no.
You can jump in. You can still jump in. I'm going to show questions so our friends at home can play along. There you go. There's question number 1. Go ahead, commit to an answer. Write it down on paper. Hey, question number 2. Think it through. Read it carefully. Here is question number 3. Where are you today? Why aren't you here? I don't know. Question number 4. You got this. I believe in you. Just pause if you need more time. Question number 5. When I stop this recording, I'm going to tell them all a secret question that's going to be on their quiz. I'm just kidding. That'd be so mean.
No, you should have done that. You should have just cut them off.
You should.
Do you hear that? They're throwing you under the bus. Okay. Are you close? All right, here we go. Yay! Good job.
All 9 of us.
Yay! All 9 of you. Ah, is there an ozone shield today? Yes. Okay. It's actually getting better.
It is?
Mm-hmm. Yeah, but that's through work. But now we're reversing all those changes we made so we can make it worse.
Yeah.
Goals. Hashtag goals. Yes, Miller. Protocells obtained energy as heterotrophs. Heterotrophs. You could say chemoheterotrophs, but this says chemoautotrophs, which means they would be like an autotroph, and they weren't. That came later. Okay, and 5. Good job. All right, I will look for a quizzes, but otherwise make some great choices.